Okay, section 9.6 for chapter 9 is called the ideal transformer at no load, voltage ratio. And so you begin the discussion here, and he says before we get into particulars of practical transformers, which means more of what are we really dealing with, we explore this transformer in an ideal sense. And exactly what does that mean, an ideal transformer? What are its characteristics? Okay, so we're going to define that. And at first you might say, well, what's the usefulness of that? Well, what we're going to find out is the actual practical transformer very closely models the ideal model. So let's look at this, and I've got a list here of these characteristics of an ideal transformer, and then we'll look at an example of this ideal transformer, and then we want to after this actually connect a load to this and see how things really change after that. So what are the characteristics of an ideal transformer? He lists those here in beginning with 9.6. He says that these properties are defined as no losses. Okay, and what do we mean by no losses? Well, we're talking about no losses that we saw maybe when we were looking at motors and generators in terms of I2R losses, heat losses in coils, that sort of thing. So what we're going to do, we're going to basically assume that there are no losses in an ideal transformer. We're also going to assume that it's something called infinitely permeable, which really means that we had this idea that at some point the ferromagnetic material that electrical machines are built around becomes saturated with flux, and we can increase current, but at some point it's saturated and it just cannot contain any more flux at some point. But we're going to say for our ideal transformer that it is infinitely permeable. So you're sort of assuming this straight line relationship between increased magnetizing current and flux. And then the other thing that we're going to assume is that the flux produced, say by the primary, is completely linked by the secondary. In other words, there is no leakage flux that we have to account for. And that will serve as our model for the ideal transformer. He goes on to say that practical transformers have properties which very much resemble these properties of an ideal transformer. And the reason that they do is that we operate them in a range that makes sure that that happens. Okay, now we could go out of this range. And not see these characteristics, but if we operate them within a certain range, the practical transformer will very closely model the ideal. The practical will look like the ideal. So let's build this thing, and then we'll make some applications for it.